Alright, this is the review for the Unit 3 exam that covers both Chapter 5 and Chapter 6. The first Chapter 5 review. We're going to use the distance formula to prove that triangle ABC is either scalene, isosceles, or equilateral. So these are the coordinates for A, B, and C. -3, 2 for A, -5, -3 for B, -1, -3 for C. Let's go ahead and graph those first so we can kind of have an idea of what we're looking at. So there's A at -3, 2. B is at -5, -3. C is at -1, -3. So to decide if this is scalene, isosceles, or equilateral, we're going to need to find the distance from each side, because scalene means no sides the same, or no sides are equal in the triangle. Isosceles means two sides equal. And equilateral means all three sides are equal in the one triangle. So I have to find the length on all three sides. So the easiest one to find first is BC, because it's pretty straight. It's straight horizontal. If it's either vertical or horizontal, you can just count. So that's 1, 2, 3, 4. That's a distance of 4 units. Now for the rest of them, for AB and AC, we're going to need to use the distance formula to find their lengths, and then to decide whether they are scalene, isosceles, or equilateral. So the distance formula is distance equals big old giant square root x2 minus x1 squared y2 minus y1 squared. So I'm finding the distance between A and B. A, which is at -3, 2. B, which is at -5, -3. So I'm just going to plug that in to the distance formula. Okay. x2 would be -5. Minus x1 would be -3. y2 is -3. Minus y1 of 2 squared. This becomes a plus, so it's -5 plus 3, which is -2 squared. -3 minus 2 is -5 squared. -2 squared is a positive 4. -5 squared is a positive 25. And that gives me a square root of 29. Since the square root of 29 is not equal to 4, I can rule out that it's equilateral. But I need to decide whether it's scalene or isosceles. So for that, I need to know the length on AC. So again, A is at -3, 2. C is at -1, -3, and I'm going to use the distance formula. So x2 in this case would be -1 minus x1 of -3 squared. Then y2, -3 minus 2 squared. This is a plus, so this is 2 squared. This is a -5 squared. 2 squared is 4, -5 squared is 25, and I also get the square root of 29. So these two lengths are both the square root of 29. So the triangle is isosceles because it has two equal sides. Okay. Alright, so let's look at number 2. We need to find the measure of angle A. Angle A is down here, and the only thing they give us is that this is a triangle. We know that all the angles in a triangle should add up to 180 degrees. So I should take all these angles in here. X plus 67 plus 70 plus x plus 57. They should all add up to equal 180 degrees. X and x is 2x. 67 plus 70 plus 57 is 194. And that should still equal 180. If I subtract 194 from both sides, I'll get that 2x is equal to negative 14, and therefore x should be negative 7. I don't stop there because they want me to find the measure of angle A, so I need to substitute it back in for this. A is equal to x plus 67, so negative 7 plus 67 is equal to 60. So the measure of angle A is equal to 60 degrees. On number 3, I have these two interior angles and an exterior angle out here. So I should remember that the two interior angles should sum up to equal the opposite, the exterior angle on the outside. So 7x minus 2 plus 11x minus 6 should equal 100. Now another way I could have solved this, or I could have done this, is I could have figured out, oh, that this, since this is 100, this is being a linear pair, this has to be 80 degrees. So then I could just work with all the inside angles in a triangle. I could have done 7x minus 2 plus 11x minus 6 plus the 80 should add up to equal 180 degrees, because all the angles in the inside of a triangle add up to 180 degrees. Notice if I started off like that and I subtracted 80 from both sides, I would end up with this, 7x minus 2 plus 11x minus 6 equals 100. So you can see that both ways turn out to be the same. We continue to solve this, combining 7x and 11x to make 18x, negative 2 and negative 6 to make negative 8 equals 100. If I add 8, 18x equals 108. Divide by 18, we get x equals 6. Again, I'm not done. I need to find the measure of angle A. A in this case is the same as 7x minus 2. So if I substitute 6, 7 times 6 is 42. Subtract 2 is 40 degrees. Number 4, I need to find the measure of this angle in here. So I want to take it one triangle at a time. I'll take the top triangle because it has two angles labeled here, 55 and 25. I know that all the angles in the interior of a triangle add up to 180. So what I can do is add 55 and 25. That's 80. And I can go ahead and subtract it from 180 to get that the inside angle right here is 100. Okay, that's the missing angle in that triangle. I know these are vertical angles right here because they're crossing each other when two lines intersect. So anytime you have vertical angles, they are always equal to each other. So this is also 100. So now I'm in this triangle. Here's 100, here's 21, and there's a question mark there. I can add 121. And I go ahead and subtract it from 180. And then I get 59. In number 5, I can do it in a couple ways. The shortest way is to, again, remember that the interior angles add up to equal the exterior angles. Sorry, the remote interior angles here would add up to equal that exterior angle. So 85 plus 30 is 115. Now if you didn't remember that, you would try to solve for this angle. You would do 85 plus 30, and then you subtract it from 180, and that will get you 65. Okay, and then you realize, oh, to get the question mark, these form a linear pair, that's 180 degrees. I would take the 180 and subtract that 65 back, and end back up at 115. So either way, if you can remember that these two angles add up to equal the outside one, you're good. And even if you forgot that, you can find out this missing angle in here, add these up, subtract from 180, and subtract 180 to get that angle back. So from 6 to 11, we're supposed to decide which theorem or postulate or whatever can be used to prove that the triangles are congruent or not. So remember that your choices are SSS, SAS, ASA, AAS, or HL. So number 6, I know these sides BD is congruent to BD, so that's reflexive. And so I have this side marking, this angle marking, and this side marking. So this side marking, angle, and side. So these two triangles are congruent by side, angle, side. Two sides and the angles in between. Two sides and the angle is in between. In 7, again, I have FH, so it's congruent to FH by the reflexive property. I have an angle marking, a side marking, and an angle marking. And the same over here. So this is angle, side, angle. Two angle markings, and the side marking is right in between the two angles. In number 8, I only have this side marking and this angle marking. There's nothing else here that I can use. There's no reflexive property, and there's no vertical angles. I just have two sides, a pair of sides, and a pair of angles. There's not enough information here. This is not possible to prove that the triangles are congruent. In number 9, I have again the reflexive side. These are two angle markings. Okay. So I have angle, angle, side because I have two angles and the side is not in between the two angles. In number 10, I have all side markings, so I have side, side, side. In number 11, I have that angle marking, the side marking, and that's all in each triangle. I need something else. There's not enough information here. In 12, 13, and 14, I need to prove that these two triangles are congruent. Okay? So I need to start off a list of statements and reasons. I'm going to say just S and R for short. The first statement I can make is that this length, DE, is congruent to that side, FE. And I can tell because of these markings. But I don't write down markings, I write down that it's given to me. The next thing that's given to me are these angles. These angles are congruent to each other. I cannot say angle E is equal to angle E because it's confusing about which angle you're talking about when you say angle E. So I need to be more specific in naming them. D, E, G is that angle there. Is congruent to this angle, F, E, G. And that's given to me. Okay. So that's all that's given. So I need something else. I have a side, an angle, and this is given to me. Or actually not given to me, but this is equal. Side EG from the left triangle is congruent to side EG from the right triangle. Okay. And that's because of the reflexive property. Since I have two sides and the angle is in between, I can stop and say that the triangles are congruent. Triangle DEG is congruent to triangle FEG because of side, angle, side. I have two sides, the angle is in between. On 13, I'm going to do something similar, so statements and reasons. I'm going to start off with side here, JH. Congruent to LM, That's given to me from the markings. Angle J is congruent to angle L, given to me from the markings. And these angles are equal to each other. They're vertical angles. And again, I cannot say angle K and angle K for equal angle K like I did up here. I can say angle J and angle L, because if I say that, there's no confusion about which angle I'm talking about. If I say angle K, there can be confusion about which angle I'm talking about. This one, this one, this one, this one, or this one. So to be more precise, angle JKH congruent to angle LKM. And those are vertical angles. Vertical angles are always congruent. Okay, so I have a side marking and two angle markings. The side is not in between. So since the side is not in between, it's going to be AAS, triangle JKH is congruent to triangle LKM. And 14, again, statements and reasons. First statement is NR congruent to QP. That's given. NP congruent to QR. That's given from these markings. PR should be congruent to PR because it's reflexive. And I used all side markings. So the triangle should be congruent. Because of S. Sorry. Okay. 15. I don't even have a picture. I think the picture got drawn out. So it should, I think it should be like this. Here's A and B, and B and C. They should be equal to each other. Or sorry, they should be parallel to each other. That's given to you. B is congruent to angle D. Supposed to prove at the end that sorry, that's not the picture at all. So here's the picture for number 15. We need to do this proof. We are supposed to go from the given statements that AB is parallel to DC and angle B is equal to angle D, congruent to angle D, and use that to prove in the end that BC is congruent to DA. So the first statement they wrote is AB is parallel to DC, and that was given to us right here. Right after they say that the lines are parallel, they say that this angle BAC, this one right here, is congruent to this angle DCA. Now those angles form alternate interior angles. So if your lines are parallel, then alternate interior angles are congruent. The next thing to do is they state that angle B is equal to angle D, and that's given to us. Then they state that AC is congruent to AC, and that's reflexive property. And afterwards they state that the two triangles are congruent. Triangle ABC is congruent to triangle ADC, or CDA. And there's an angle marking there, an angle marking there, and a side. Angle marking, side. So the triangles are congruent by angle, angle, side, because you have two angles, and the side is not in between the two angles. And since both triangles are congruent to each other, these corresponding parts should be congruent. So that's why BC is equal to DA. The corresponding parts of congruent triangles are congruent. Right. So on to chapter 6. In number 1, I'm supposed to just name the following segments. Start off with an angle bisector. So an angle bisector is a line, a segment, or ray that cuts an angle in half. So that looks like it's HK. Because HK is cutting angle H in half. And you can tell because of these markings here. Those angle markings mean this angle is equal to that angle. That means that angle was divided into 2 equal parts. An altitude is how tall an angle, a shape is. So something that measures how tall the shape is would be GH. A median connects a midpoint to a angle or a vertex. So I could start here. N is the midpoint between this side because this gets bisected, these marks here, but it doesn't get connected to the opposite corner, opposite angle G. So that's not a median. M is a midpoint here. You can tell by these 2 marks right here. And it gets connected to the vertex J. So MJ is a median. Perpendicular bisector means to cut a side in half at 90 degrees, and that's LN. Here's the bisected part, and here's the perpendicular part. For number 2, I need to construct a centroid. So a centroid is made from medians. And like we discussed earlier, a median connects the midpoint to the vertex, or the opposite corner. I'm just going to write corner. So I need to take my compass, and I need to find the midpoint. I need to create a way to make a midpoint. So I'll start here. I'll put the compass down at that endpoint. I'll open up my compass more than halfway and do a half circle. I'll flip it around, go to the other vertex, and do that. Normally I would connect these 2 spots, but that would create a perpendicular bisector, and I need a median. So I use that to get my midpoint. There's a midpoint, and I connected that to the corner. So I'll do this again on the other sides as well. I'll bisect this side so I can find a midpoint. Again, I line it up, but I do not create that line. I use it to find the midpoint, then connect that midpoint to the opposite corner. And again, on the final side. Midpoint, corner. Notice how all 3 lines meet at one single point. All 3 medians meet at one single point. That one single point is called your centroid. In number 3, I'm supposed to construct the incenter. That's made from angle bisectors. So I have to bisect every angle in here. So I go to an endpoint, or a vertex, do an arc. Notice these 2 points of intersection. Put my compass there and there. Create 2 little arcs and connect the point of intersection to the vertex. So that's an angle bisector, and I need to do this 2 more times because I need to bisect every angle here. Again, at the very end, I should have 3 angle bisectors that intersect at one point. This one's slightly off. So, something like that. The deal about the in-center is that you can put your compass there and you can get a circle inside your shape if you did it correctly. Mine was a little off, but you get the idea. Number 4 is supposed to solve for x and find the length of the side. So here, this length here is called the mid-segment. Mid-segment connects to midpoints. So kind of the property of the mid-segment is that it is half the length of the side that it's parallel to. So a lot of people just set up 2x minus 7 equals 3x plus 1 without thinking about it. These lengths don't even look like they're equal to each other. This bottom one is way longer than that one. So what needs to happen is I need to double this length in order for it to be equal to the parallel side. So doubling that makes it times 2, and I can distribute that. That's 4x minus 14 equals 3x plus 1. Subtract 3x. Add 14. Here that x is equal to 15. Now I'm not done. I'm supposed to find the length on each side. So, of the side. 3x plus 1 is the side. That's the mid-segment, so I don't need to worry about that. So 3 times 15 plus 1, that's 46. So the side is 46 because x is equal to 15. For number 5, they tell me that the perimeter of triangle ABC, the big one out here, is 96. But they don't tell me any of those lengths. They only tell me that this length in here of this mid-segment is 2x, 3x plus 2, and 4x plus 1. So if this is 96, and the mid-segment is half of each of the sides, it makes sense that the perimeter of this inside triangle should be half of 96. So 96 divided by 2 is 48. So 4x plus 1 plus 2x plus 3x plus 2 should equal 48. If I combine like terms, 4x, 2x, and 3x make 9x. 1 and 2 make 3. Subtract 3. And you can see that x is equal to 5. So number 6, they tell me that D is the centroid of ABC. So you know that the centroid has like some funny properties. Well, however long this is, double it and you'd get the longer length. And if you get the total, they tell me the whole thing, divide it by 3 and that will give me the shorter length. So let's start with the problem. So AD is equal to 12. That means this part is 12. It doesn't make sense for this part to be 12. This is a lot smaller than that part. So this is twice as long as that part. So if I take 12 and divide by 2, that gives me this part being 6. And they want the length of AG. Well, so 12 plus the 6 is 18. They tell me that BE equals 9. This whole section is 9. Well, this gets divided into 2 separate parts, where this part is twice the length of that one. So I'll take 9 and divide it by 3. That gives me that this part is 3, That means this part is 6 to be left over to make 9. You can still see that this length is twice the length of that one. So BD is equal to 6. They tell me that FD is 7. That means this part is twice as long. This part would have to be 14. So DC is 14. Number 7 and 8, I have to solve for x. This is a perpendicular bisector. These are two equal sides right here. This side's reflexive, so we have equal congruent triangles by side, angle, side. So that means these parts should also be congruent. The 4x minus 3 should be equal to the 3x plus 2. So using that to solve for x, we get that x is equal to 5. Same scenario here. This is reflexive, so that this is angle, angle, side, so the triangles are congruent to each other. So these parts should be congruent to each other. If I subtract 2y, subtract 8y from both sides, I get negative 2y equals negative 7. Divide by negative 2, y is 3.5. Number 9, I'm supposed to explain why a triangle cannot have these lengths for the three sides, 6 centimeters, 10 centimeters, and 17 centimeters. It's because of the triangle inequality. It says the two shortest sides of a triangle need to add up to be larger or bigger to be than the longest side. So 6 plus 10 are the two short sides, and they only add up to 16. And that's not bigger than 17. 16 is not greater than 17. When you have that, you can't form a triangle with those lengths. So the two short sides must be greater than the last side. On number 10, two short sides are given here. Two sides are given here, 9 and 17. And we need to describe the possible lengths for that third side. So I don't know what the third side has to be. It could be all sorts of numbers. It could be 20. Now you could have a triangle that's 9, 17, and 20, because 9 plus 17 is definitely bigger than 20. But we need to find all the possible lengths. So to get the highest it can be, so if you do 9 or 17 plus 9, that gives us 26. Okay, 26 is the most it can be. It cannot equal 26 though. So like 9 plus 17, that's 26. 26 can't be greater than 26 it's actually equal to. So I have to say that x has to be smaller than 26. And on the small side, there's a restriction on how small it can be. And to figure that out, we do 17 minus 9, which is 8. So the possible lengths on that third side, the third side needs to be bigger than 8, but smaller than 26. So in 11, I'm supposed to list the sides of this triangle in order from shortest to longest. But they give me angles. This one's 51, that's 47. So I need to figure out what all the angles are first before I can figure out which sides are shortest to longest. So I'll add 51 and 47. That's 98. Subtract that from 180. And that's 82. Now opposite the smallest angle should be the shortest side. Here's the smallest angle. Across from it should be the shortest side. So DF is the shortest side. 51 is kind of the number that's in between. Across from it should be the next shortest side. So EF is in the middle, and the longest should be across from the 82, and that's DE. Lastly, number 12, just list all the angles from largest to smallest. So opposite the largest angle, sorry, the largest side, the longest side should be the largest angle. 6.8 is the largest side, opposite that would be angle R. 6.1 to make angle P, and lastly 5.9 is the shortest side, it should make the smallest angle, angle Q.